Let's take a look at an integration question from Zhonghua Secondary. Fx is such that f prime x equals to -2 sine 4x plus cos 3x. Given that f0 equals to 0, find the exact value of f pi over 4. Now, if you notice, there's no integration sign in the question, so you are given the first derivative. Knowing that integration is going to reverse the process of differentiation. So this question over here, if you're going to reverse this one, this is the first derivative, you are going to take an integration. So what you have here is that you will reverse this f prime x back to fx. So same thing, we're going to apply integration to the left. We're going to apply also integration to the right hand side. So I'm going to write integration sign now. Integration, I'm going to put a bracket of this expression here in trigonometry. And remember to write what are you integrating with. So in this case, we will be dx. Okay, now let's look at the second part of this. We're going to find out how to integrate trigonometry. Let's think of our differentiation process first. I'm going to write it here. So if you recap, differentiating sine x, you will get cos x, and differentiating cos x, you be careful of this c, you will get a negative sine x. Now doing the reverse, if you integrate cos x, so that's how we write it, we write dx, you'll get back the result, which is sine x. And in general integration, we add a plus c at the back, which is a constant. So same thing for this one here. But instead of writing integration of negative sign, I'm going to write integration of sine x and put my negative to the other side. So I'll get my result as negative cos x plus c. So take a look at this one here. So what are the two things you need to be careful is when you differentiate cosine x and when you integrate sine x. Why? Because these two results will lead you to the opposite sign for the answer. So let's go back to this question over here. When we are integrating sine, we're going to change this -2 to +2. And we're going to change sine to cos. Copy back this angle. And remember to divide by coefficient of x. So in this case is 4. So let's do this one here now. Integration of cosine will stay the same sign. So it's a plus. I'm going to write a plus here. Changing cos to sine. Copy back the angle 3x. Divide by coefficient of x. In this case is a 3. Now remember to put plus c here, which is a constant. So that's the reason why you are given an extra information. f0 equals to 0. So I'm going to use that, but before I use that, let me just lower down this 2 over 4 to half cos 4x. And I'm going to pull out this fraction, 1 over 3, and write sine 3x plus c. Okay, so let's use the information given to us, which is f0 equals to 0, which means I'm going to substitute 0 and my answer will be 0. Okay, so that means when you substitute x as 0, fx will be 0. So I'm going to put this one, fx here, I'll put as 0, and I'm going to substitute 0 times 4 is still 0. So same thing over here, 3 times 0, 0. Then you will be a bit careful for cos 0 here. If not, you click your calculator. If not, you take from the graph. Cosine 0, this position here is going to be a 1. Okay? So half times 1 plus, for sine is okay. So sine graph here, the starting value here will be 0. So here will be 0 plus c. So moving half there, so I'll have c answer as negative half. So now I have c value. Let me rewrite fx now here by replacing c as negative half. So what we need to find? F of pi over 4. Let me insert pi over 4 here. So we have cosine 4 times pi over 4 plus 1 over 3 sine 3 times pi over 4 minus half. Let's lower down this one here. So 4 and 4 cancel. So what we're going to find is half cos pi plus 1 over 3 sine 3 pi over 4 minus half. So cos pi is going to be this one here. Reading downwards, the answer is -1. If not, you can click calculator as well. So half, I'm going to replace cos pi as -1. Now what happened with this sine 3 pi over 4? Let me erase the part over here and explain. 3 pi over 4 is in radian. So if it's hard for you to see, let me write down here. 3 pi over 4 in radian is also equivalent to changing the pi to 180. You'll get this answer is 135 degrees. So how do we write down the value of sine of 135? So remember, 135, when you read the angle, is going to be in quadrant number 2. That's where 135 degrees is. So this reference angle here is going to be 180 minus 135. You will get 45 degrees. Okay, the angle and its reference angle. Now knowing that 45 and 135, where are the two angles? 45 is in quadrant 1, 135 is going to be in quadrant 2. And what value are we reading? Sine value. So sine value in quadrant 1 will be the same sign as in quadrant 2. So which means we know that sine 3 pi over 4, okay, will be equivalent to the result of sine 135, which is also the value of sine 45 degrees. So in this case here, if you remember, sine 45 degrees is going to be 1 over square root 2. If not, just put the square and do the reverse sign, okay? So this value here, I'm going to replace 1 over square root 2. So next step over here, this is minus half. This is minus half. I'm going to get -1. I'm going to move this one in front. And if you want to do a rationalization step, you can. That's already the answer. So let's say you are doing a rationalized set of SUT2 over SUT2. We multiplied it to rationalize. So what we get here is SUT2 times SUT2 going to be 2 times 3. That's 1 over 6. I'm going to write the SUT2 at the center now here. Okay, so 1 times SUT2 is SUT2. So instead of writing at the numerator, I just put it at the right side, -1. So that's our answer for this integration question.